Hello there, welcome to my channel. Okay, in this video I'm going to explain and discuss with you chemistry paper 4. Okay, chemistry paper 4, February March 2018. This is 42, yeah, and the time given for this paper is 1 hour and 15 minutes. Okay, let us go to the first question. Okay, first question here. This question is about gases. Okay, the following substance are gases at room temperature. Letters A to F and all the substance here. Okay, identify by letter. So they want you to answer by letter. Okay, a gas which combines with water to form acid rain. So it should be acid rain is a sulfuric acid. Okay, it's a sulfuric acid given by the formula H2SO4. So it is a sulfuric acid. So your best choice here will be the letter A. Okay, so here will be the A. Okay, now let us look at the second one. Two gases which exist as a diatom molecules. Diatom molecules means something like we have a chlorine. Okay, we have a chlorine which is with 2, and this is we call it as a diatomic molecules. So if you see here, this is 2 marks and here must be D. Okay, so the another one should be C here. Okay, this is a diatomic molecules, C and D. Okay, a gas which bleaches damp litmus paper. Okay, bleach, which gas has the bleaching characteristic should be chlorine. Okay, so should be donkey here. Okay, the next one, a gas which is used as an inert atmosphere in lamps. Inert atmosphere, so this is a group 18. Okay, the group 18, so the group 18 should be argon, B. Okay, two gases which are found in clean dry air. So we have nitrogen, oxygen, carbon dioxide. So we have to choose this. So 1AV, we have our answer argon. Argon inert gas, they do have. Another one is F, carbon dioxide. Okay, two gases which are found in a refinery gas. This is the oil and natural gases related. So here should be methane, and this all is carbon. Okay, so we will have a GH here, G and also H. So here's another 2 marks. Okay, now we move on with the next question. Okay, as we can see here, question B, we have nitrogen and also fluorine compound. Okay, it has covalent bonds. What is a covalent bond means? Okay, here the answer here will be your answer here will be molecules that forms a substance by sharing electrons. Okay, by sharing electrons. Okay, now let me scroll down a bit. Okay, here complete the dot and cross diagram to show electron arrangement in a molecule of nitrogen fluoride. Okay, so here nitrogen, please remember it has 5 valence electron. Okay, the valence electron here will be 5. Valence electron, here you have 5. So your, based on this Lewis structure, we will have 5. Okay, and then if you look at fluorine, fluorine has 7 valence electron. So the arrangement here will be 1 dot. I use dot for fluorine. So you have 7 dots there. So this one will be arranged over here. So let me change the color. So for fluorine, I am using black color. So here's 1, 2, 3, 4, 5, 6. Same goes to here. 1, 2, 3, 4, 5, 6. Here. 1, 2, 3, 4, 5, 6. And then as you can see, I'm going to draw the bonding. Okay, this is the bond. So all of them achieve a single bonding, and they do have, let me circle this. Okay, if you look at this fluorine, they have 8 electrons. 8 electrons here and 8 electrons here. They have been stable. Okay, now I use a green color to indicate the electron sharing by nitrogen. Okay, alright, so we have 1, 2, 3, 4, 5, 6, 7, 8. Now if you look at it, here, this part, the one that I shade with a yellow color, we have 2 there. Okay, we have 2 electrons. So I'm going to place it over here. 2 electrons. So here will be X and dot, X and dot, X and dot. Okay, don't forget we have another 2 more electrons for nitrogen, and we use dot for fluorine. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is the total 3 marks for us. Okay, now we move on with the next question. Okay, air is a mixture. Nitrogen and oxygen are the 2 most common gases in air. Okay, what is meant by the term mixture? Mixture means the 2 substances are not combined chemically. Okay, so there are 2 substances not combined chemically. Or you can say can be separated physically. Okay, so they have choices of answers for this. Okay, state the percentage of oxygen to the nearest whole number in a clean dry air. So let me give you a small knowledge over here. Okay, in the air we have nitrogen gas, oxygen, carbon dioxide, we have inert gas. Okay, so nitrogen stands about 70, this is percentage. Okay, this is percentage. Nitrogen gas stands about 78%, oxygen is 21%, carbon dioxide is very low, is 0.03%. Inert gas is about cumulatively about almost 1, so to be accurate is 0.98. And we also have water vapor, bacteria, dust. This is the air. So percentage of oxygen is 21. Alright, so let us move on. Let me scroll it upward. Okay, there you can see the next question there. Okay, describe the steps. Okay, describe the steps in the industrial process which enable nitrogen, oxygen to be separated from clean, dry air. Use scientific terms in your answers. Okay, to separate them, firstly, air is condensed. Air will be condensed into liquid air. Okay, this is we'll be using a very high pressurized compressor to condense it. And secondly, once it condenses, the liquid air will be going through fractional distillation process. Okay, where here inside this fractional distillation, the liquid water will be boiled at a different temperature. So okay, so you can say the liquid water, the liquid air will be boiled. Okay, will be boiled following and separate at different temperatures, and condense the vapor. Here's where they will collect it. At different temperature. To obtain oxygen gas and also nitrogen gas. Okay, so this is how the process is. Okay, now which physical property of nitrogen and oxygen allow them to be separated is their boiling point. Okay, is their boiling point. It is the same process where water can be separated from alcohol. So I hope you can understand this. Okay, this is the second question. Sodium chloride, let me change the color, is a typical ionic compound. Okay, so they are formed in this way. Okay, so they are formed in this way. The diagram shows part of a lattice of sodium chloride. Complete the diagram to show the ion present. Use positive for sodium, use negative for chloride. One ion has been completed for you. So the following, the next, here you see this tree. Here will be negative, negative and negative. Here will be positive. So the opposite should be the opposite charge. Okay, here's positive, here's negative, and here's positive. So this is 2 marks. Okay, now the next, let me scroll up. Okay, so we have, okay, let us answer this. How many electrons does chloride ion have? So chloride ion, they have about 2, 8 and 7. This is for all chlorine. When they form an ion, negative ion, they'll accept 1 electron. So you'll be getting 2.8.8 is the electron arrangement. So here we'll have 18. Identify an element which has an atom with the same number of electrons as a sodium ion. Sodium has about 11 electrons with a configuration 2.8.1. So when they donate 1, it will become a positive ion. So this valence electron here will be eliminated. So you only will have 2.8. So here is 10 electrons. Okay, 10 electrons for sodium ion. So now which element has an atom with the same number of electrons? Let us find it out. Okay, this is the periodic table that we have, and you can see at this part. Okay, so here is the, okay, so at this, here we have a neon with a proton number 10. So this is the answer for this, right? So back to this question. So this is a neon, or you can write in full. Okay, now the next one. Okay, electrolysis. Okay, electrolysis of a concentrated aqueous sodium chloride is an important industrial process. What is meant by the term electrolysis? Okay, this is a breakdown of ionic compound. Of ionic compound. We can put there, it's either molten or aqueous. Okay, just put the molten or aqueous. Okay, by electricity, or you can say electric energy, or by electric current. Okay, you can see there's a lot here. Okay, so this is the main definition of this electrolysis. So this is 2 marks over here. Name the product of electrolysis of concentrated aqueous sodium chloride. So we will have our, okay, so let me explain to you a bit of this, the side here. Okay, now when we have, okay, let's say this is the anode, positive, negative. Okay, so this part is this concentrated sodium chloride. So here we have ion axis over here is sodium plus hydrogen, chlorine, iron, and water hydroxide. Okay, so this is the positive, which is anode, and this is a negative, which is the cathode. So here there will be 2 ions, chlorine and also hydroxide, will be flowing here, and here will be sodium and hydrogen will be flowing here. Okay, since it is under the condition of a concentrated, so chlorine gas will be chosen to discharge. So when the chlorine gas is chosen to be discharged here, your RF equation here will be chlorine. You will have a chlorine atom. It will release an electron, but chlorine will never appear as single, so they will appear as a diatom here, 2, 2. So here you have a chlorine gas. At the cathode here, hydrogen will be discharged because it is the lowest in electrochemical series. So they will accept electrons that are flowing here, this part. Okay, so and they'll become hydrogen. Same with this case. Here we have hydrogen H2. So here we have 2 and 2. So the balance, if you notice, here we have left of sodium and also hydroxide. So what happens here? They will have a reaction, sodium plus with hydroxide ion. You'll be having a sodium hydroxide. So here we will have 3 products there: chlorine gas, or this one should be Cl, chlorine gas, hydrogen, and sodium hydroxide. Okay. So I hope you can understand this. It's a simple diagram to explain this question. Okay, now let me go back to the question. So here we will have, okay, so here we will have hydrogen, chlorine, you can put chlorine gas or hydrogen gas, and it's also sodium hydroxide. Okay, now they are asking for half ionic, half equation for the reaction at the cathode. So at the cathode is this the cathode. Okay, the hydrogen's reaction. So let me write it back. So here will be 2 hydrogen, they will receive 2 electrons and they will form a hydrogen gas. Okay, so this is a gas. So we have 2 marks over here. Okay, we move on with the next question. Okay, now for C, silver chloride can be made by reacting aqueous sodium chloride with the aqueous silver nitrate, and this is the equation here. The other product of this of the reaction is sodium nitrate. Okay, so what we can understand here, this is not soluble. Okay, it is insoluble. However, all this nitrate salt, okay, they are soluble. So this one will form a precipitate. Argentum chloride will form a precipitate. The student attempt to make the maximum amount of sodium nitrate crystal. Alright, okay, so the process involves 3 steps. The student added aqueous sodium chloride to aqueous silver nitrate and stirred. Neither reagent was in excess. Okay. The step 2, the student filtered the mixture. They take out this argentum chloride. The student then washed the residue and added the washings to the filtrate. The student obtained sodium nitrate crystal from the filtrate. Okay, describe what student observe in the first step. Okay, the first step is what they will observe is they'll observe the formation of this precipitate, which is in a white color. Okay, the argentum chloride that I mentioned just now. So here we will have a white precipitate. Let me scroll. Okay, now why was residue washed in a step 2? Okay, here this is the step. They wash because to ensure all sodium nitrate. Okay, all sodium nitrate was collected because it is soluble in the water, so they wash it. Alright, so the number 3, give the name of the two processes which occur in step 3. They get this residue and then until they form a sodium nitrate crystals. Okay, from a liquid to a crystal. So you will have to make the water to evaporate. So you can say that evaporation process, or you can boil it to make it more faster, and then you have to crystallization it. So this is the crystallization process. Okay, it's a crystallization process where you will have after the first step, boiling, losing water, you have to dry it. Okay, dry, cool. To make it perfect, you have to repeat the evaporation and boiling again. Okay, so these are the two steps that we have to follow. Okay, let me scroll down. Okay, now we come to the next question here. Okay, so the student started with a 20 centimeter cube of 0.2 molarity of sodium chloride. Okay, let me copy down the equation here. So we will have sodium. Okay, got it. So here we will have argentum chloride and sodium nitrate. Okay, always remember when you have a calculation questions, please copy down your equation to make it easier for you. Okay, so and then you have to place the number here. So everything is 1. Okay, everything is 1 over here. Okay, the student started with 20 centimeter and molarity. So the amount they used, so they want it in mole. So what happened here, we can use the formula mole equals to molarity multiplied with volume, and this volume must be in centimeter cube divided by 1000. It's the same. It's the same with this V over 1000. Okay, I'm going to change the centimeter cube into dimetric cube. So here your calculation here will be M is 0.2. Let me erase this part. So here your calculation can be done by 0.2 and your volume is 20 divided with 1000. Okay, let me calculate this. Divided by 1000. So I'll be getting here. 0.004 mole. Okay, yield of sodium nitrate crystal was 90%. Okay. Now to calculate the others. Okay. So everything here we will have 0.004 mole, because I follow this number here. The ratio is given, is everything is 1. Okay, so mole for sodium nitrate is also 0.004 mole. So when they're asking for mass, what we should do is we have to multiply the mole with RMM. So the RMM you can refer to periodic table. So the Na is given by 23, N is nitrogen is 14, and oxygen is 16. Okay, so to calculate, sodium is 23 plus with 14 nitrogen, and oxygen is 16. 16 multiplied with 3, you are getting there about 48. Then you plus all, you got about 62, 23, you got about 85. So RMM is 85. So we multiply, okay, we multiply 0.4. So let me show you the calculation here. Okay, 0.04 multiply with 85, you'll be getting the 0.34 gram. 4 marks over here. Alright. Okay. Write down the chemical equation for action of heat. Sodium nitrate crystal. So sodium nitrate, when they heat it up, okay, let me write down sodium nitrate, you'll be getting sodium nitrate plus with oxygen. It will produce oxygen, okay, because this is a very reactive substance here. So this is your answer. Okay, so total you will be having here 2 marks. Okay, let us move to the next question. Okay, limestone rock is mainly calcium carbonate. This is limestone cycle is shown. Each step is numbered. Okay. Limestone, calcium carbonate. Step 1, heat. So if you heat it up, you'll be getting here calcium oxide. Okay, so here's a calcium oxide. Then you add with water, you'll be getting calcium hydroxide, slag lime, and this is we add with excess water, you'll be getting the lime water. Okay, so just remember this part. Okay, heat. Now let me move down. Okay, complete the box to give the chemical name and formula for lime. Which step involves a physical change? Physical change. Here steel is a solid. This is also a solid. Add limited water. Here is still a solid. When you add with the excess water, this one will change into aqueous. Or you can see this direction in this notation here as. Here's S, and here is AQ, so it stands for aqueous. So we can make it a step 3. Just write it down as a step 3. Okay, let me scroll further down. Okay, what type of reaction is step 1? Okay, step 1, anything that is heated up, okay, and then they decomposed, it is called as thermal decomposition. Okay, so this one is a thermal decomposition. Okay, suggest how step 2 could be reversed. Step 2 here, they are referring to this part. Okay, they are referring to this particular part here, where they want to reverse from this process to this process. Okay, so when we go back to the question, okay, suggest one thing, so you can say is by heating process. By heating process. Okay, write a chemical equation for step 4. Step 4 is this: lime water to limestone. Okay, this is step 4. So you have to add carbon dioxide. So calcium hydroxide add with carbon dioxide to form calcium carbonate. Okay, so that is, write it down. So here will be calcium hydroxide. You add with carbon dioxide to form calcium carbonate, and then the H here, okay, the H here will form water. Okay, why step 4? Explain why step 4 is a neutralization reaction. Refer to the substance reacting in your answer. Neutralization, why step 4 is neutralization? So basically this is the step 4. Okay, what we can see here, this is it contains hydroxide. So calcium hydroxide has alkaline properties. Okay, has alkaline properties. Okay, however, if you can see this carbon dioxide is acidic. So what happens when you have an alkaline mixed with acidic, and you will form a neutralization reaction. Okay, so this is the explanation for this question. Okay, now let us move to the next question here. So dolomite is similar rock to limestone. Dolomite contains magnesium carbonate. Write a chemical equation for reaction between calcium carbonate with dilute nitric acid. So when you have acid and carbonate metals, you will form okay, so we have acid. Okay, let me repeat again. So when you have carbonate metals plus with acid, so you will have the salt, okay, magnesium nitrate, and then you'll be having a carbon dioxide and water. Now we have to balance this equation. Magnesium is done. Now we have nitrogen group, So NO3, we have two groups here, we have to put here 2, and then the rest is balanced. So this is the balanced equation. We are getting here 2 marks. Okay, we move on with the next question. Okay, let me scroll a bit up. Okay, now we have this question now. Okay, so here, as you can see, okay, phosphorite is another rock which contains magnesium compound. A sample phosphorite has the following. We have magnesium, silicon, and also oxygen. Okay, to build empirical formula, so we put Mg, silicon, and oxygen. Okay, first we put this mass. Okay, we can put a table here. So we just write it down, 2.73, and this is 1.58, and the oxygen here is 3.6. Okay, now we have to find the mole here. Okay, how do we find the mole? Mole is, we can find by mass divided by is RAM. So 2.73 divided by 24, which is the RAM for magnesium. 1.58 divided by silicon is 28, and oxygen is 16 there. This is 16. So when we are getting this mole here, okay, let me calculate this. So here we'll be having 0.11375. Here we have 0.0564, and here we have 0.23. Okay, now we have to divide all these moles with the most smallest mole. Okay, smallest mole. The smallest mole here is the mole of the silicon. So we have to use this to divide with everything here. So 11375 divided with this 564. So okay, 64 divided with the same. Okay, now here 0.23 divided with 0.0564. Okay, now let us get the value here. So here we'll be getting the value. So here will be equals to 2, approximately 2. Here's 1 and here's 4. So we see that we have a magnesium of of a 2, silicon is 1, and oxygen is 4. So this is the empirical formula for this. Okay, so it's 2 marks question, and total for this question is 12 marks. Okay, we move on with the next question here. Okay, ammonia is an important chemical. Ammonia is a base. In chemistry, what is meant by the term base? Okay, the base here is, we can simply, because it's 1 mark here, so we can simply write it is a proton acceptor. Okay, it is a proton acceptor. If you look at acid, it is a proton donor. Okay, now write down a word equation to show ammonia behaving as a base. So, okay, what we can do here, ammonia, just write it down, is ammonia. It reacts with, let's say, is hydrochloric acid. So what happens here is, it will form ammonium ion. Okay, it will form ammonium ion. Let me write for you this process here, and then it will combine with the chloride, so it will form ammonium chloride. Oops, okay, it's not positive here, so just write here 4 and Cl, so you'll be getting an ammonium chloride. So it absorbs, it accepts hydrogen there. Okay, so it is a proton acceptor. So you can give one example for this. Okay, now let us move on. Okay, for this question, ammonia react with chlorine. Chemical equation is shown as below. Okay, now we have this. Calculate the volume of chlorine measured at room temperature and pressure. So the volume here will be under the metric 24 the metric cube, needed to react completely with 0.68 of ammonia. Okay, let me write it down, the whole equation here. Okay, the ammonia here is 0.68 grams. So now we have to find the mole that is reacting. So we have to divide with this RMM. So nitrogen is 14 plus with hydrogen we have 3 there. So 1 multiplied with 3, we are getting 3 here. So which is 17. So 0.68 divided by 17 will be getting here. Let me use my calculator. So we'll be getting here 0.04 mole. Okay, always remember that the number in front here is here's 1. If you don't have any number, it's 1. It's a ratio of the mole. So here's 2, here's 3, here's 1, and here's 6. Okay, here is 6. So what happens here? So here you'll be getting 0.04, and here will be 0.0, just divided by 2. Okay, just divided by 2. This is all the moles. We have to follow this. So here will be 0.02, and here will be 0.06, and here will be 0.12. Okay, so now they want the volume of chlorine. So we follow this mole. Okay, 0.06 mole multiply with 24. Okay, here is a centimeter cube. So remember, 1 metric cube is equals to 1000 centimeter cube. So here should be 24,000. So when we multiply this, we will be getting, let me calculate this. So you'll be getting there 1440. Okay, it's 1440. So these are the calculation for this. Okay, we move on with the next question. So here we have a chemical equation that can be represented as shown. Okay, so we have ammonia plus with chlorine gas. Okay, so use bond energy in the table to determine the energy change for the reaction between ammonia and chlorine. Okay, first one is energy needed to break the bonds. To break the bonds is, we have to calculate breaking the bonds. So we have this nitrogen and hydrogen. So we have 1, 2 and 3. So we have 3 over here. So we have 3 pairs, and not to forget we have this 2 here, this part. So multiply 2, all together we have 6 over here. And then we have chlorine to chlorine. We break this bonding, and here we have a 3. So we have to calculate this. 360, let me choose a different color here. So it's 390 multiplied with 6, and then here will be chlorine to chlorine, 240 multiplied with 3. Okay, let us calculate this. So here we'll be getting about 2340, and here will be about 720. So all together the energy needed here is 3000 V plus. Okay, both V plus, will be getting there 3060 kilojoule. Okay, we look at the next question here. So it is, they mention about energy released when bonds are formed. So it should be the other side. So I am comfortable using this picture to explain. So okay, now we have this. Use the red color. Okay, now we have 1. Okay, so here will be triple bonding, so we have only 1, so which is about 945. And then we have hydrogen and chlorine bonding is 430 multiplied with, we have a 6 here, so it's multiplied with 6 is calculated with a 2580. So we plus this, we will be getting 3525. So which is the answer for this question. Okay, answer for this question. So it's 3525. Okay, now the energy changes. Okay, we have to understand that to break the bonding you have to absorb the heat. Okay, this one is absorbing the heat. So this is considered as an endothermic. Forming the heat, you have to release the heat. Forming the bond, you have to release the heat. So this is exothermic, this part. So when we minus this, the exothermic is higher value, right? So it is a higher value. So the energy change. So we just have to minus both of this. So we take the first one. We minus with the endo. Always your equation must be endo minus with exo. Okay. So here will be, when you minus this, you will be getting, okay, let me calculate this off. So you'll be getting the minus 465 kilojoule. Is 3 marks for this question. Okay, when you have a minus here, so what happens here is, is a exothermic. So heat is being released to this, to outside. So this is exothermic. Okay, because you can explain like heat energy being released. Okay, this is the 1 mark here. Okay, let us move to the next question. Okay, here will be ammonia react with oxygen at high temperature in the presence of a suitable catalyst to form nitrate oxide. Okay, how this chemical equation shows ammonia acting as an reducing agent. Ammonia is reducing agent, so it means ammonia should be oxidized. The reducing agent must be oxidized. Okay, must be oxidized. So we look at ammonia here. Okay, you can say ammonia. Okay, you can see nitrogen in ammonia. Okay, is oxidized. Okay, how do we know this oxidized? So you can see that here nitrogen is 3 negative over here, but in this one, okay, nitrogen, okay, when it's a combination of nitrogen also oxygen, here must be 2 negative, here must be 2 plus by logic. Okay, so if you look at this oxidation number here, negative 3, they transform to positive 2. So the ion negative 3 changes to positive 2. So it is increased. So it is being oxidized. Okay. So now we answer the second question. Suggest a suitable catalyst for the reaction from the list of metals. Give a reason for your answer. Okay, the suitable catalyst here will be platinum. Okay, will be a platinum. Okay, and then the reason for it is because it is a transition element. Remember, transition element, it has a properties which is suitable to act as a catalyst. Okay, so we move on with the next question here. Okay, alcohol are a family of organic molecules which have a same general formula. What is the name given to any family of organic molecules which have a same general formula and similar chemical properties? So we call it as a homologous series. Okay, now general formula for alcohol. Okay, so it is CN H2N plus with 1 plus with its functioning group OH. Okay, this is the formula for alcohol. Okay, propane 1-ol can be made from propane. Name the region and give the condition. So from alkane to alcohol is a hydration. Okay, it's a hydration process. So it will be going through steam, or you can see it's water. Okay, and the condition here will be, okay, for the condition you can even say it is in the presence of strong acid. It must be dilute. For example, phosphoric acid. Okay, so this is 2 marks. Okay, let us continue with the next question here. So here we have, write the chemical equation for the complete combustion of propanol, propan 1-ol. Okay, all combustion involving this organic substance you must have oxygen. Okay, you must have oxygen plus with carbon dioxide plus with water. So here, so it's 3. So let me 2 plus 1 over H. So propane is 3. So 3 H is 7 over H plus with oxygen. This is the general formula down here. And here will be carbon dioxide plus with water. Now we have to balance this equation. So here will be, let me check this. So a hydrogen is 7, is 8 here. So we put, let's say we put here 4. And then the oxygen, carbon is 3. The carbon here is 3. Oxygen is 6. Oxygen here is 6. Here is oxygen is 4. So it's 10 over here. So here you'll be getting so 5, 6, 7, 10. Here's 1. So here must got 9. So here's 9 over 2. Here is 1. Okay, so this one. Or if you want to make it in other way, we can multiply this with 2. Okay, we can multiply this one with 2, and you will have there 2, and you have here 9 oxygen. Here we have 6 CO2, and here we have 8. If we multiply with 2, if you don't like this fraction. Okay, this is 2 marks. Okay, we move on with the next question. Okay, a simple sugar can be represented as shown. The simple sugar can be polymerized to make more complex carbohydrate. Complete the diagram to show part of carbohydrate polymer made from a simple sugar shown. Okay, so here we will have, so let's say I draw here another one, hydrogen, oxygen, and we have another monomer here. So the way that the simple sugar will form a complex sugar is by condensation method, where you will have a loss of water. So here will be, to form water we need a H2O. So there will be, this one will combine to form the water. Okay, this one will disappear to form the water, and you have only oxygen. So here we will have oxygen here. Oxygen, and here as usual OH. Here is a OH. Okay, so this process is called as a condensation process. Okay, now name the chemical process which occur when carbohydrate polymer broken down into simple sugar. When you want to reverse, okay, when you want to reverse this into the simple sugar, you need to add water. So when you add water, the process is called as a hydrolysis. So what conditions are needed for this process to occur? So we need an enzyme. We need an enzyme. Enzyme, or you can say we need a heat and also acid. Is a dehydrating agent. Okay, so this is for 1 mark. Now we may move on with the next question here. Okay, chromatography can be used to identify simple sugar in the mixture. The student analyzed a mixture of a simple sugar by chromatography. All the simple sugar in the mixture are colorless. What is the name given to the type of substance used to identify the position of simple sugar on the chromatogram? So here is they already mentioned here the keyword, which is colorless. When it's colorless, you need to have a locating agent. Okay, locating agent. Okay, the student calculate RF value of a spot on the chromatogram. Complete the expression for the RF value of the spot. So here we need to write down the formula. So let me use a black color here. So here will be distance traveled by, here also distance traveled by. Okay, first off must be the substance. Let me draw for you a simple diagram here. Let's say this is the pepper, and this is the liquid. So okay, so this is the N. So this is traveled by the, so this is reach. Okay, so it should be substance, solvent. The solvent is A, so I put it as a A, and the substance here is B, so I put here B. Okay, it's a simple thing to remember. Okay, now the third one, let me scroll it down. Okay, how could a student identify a simple sugar from its RF value? So we have to compare. We have to compare with known data. Here's 1 mark. Okay, last question here. Sometimes not all the substance in the mixture can be identified from the chromatogram produced. Explain why this may happen. Because they might have a similar RF value. Okay, they might have a similar RF values. So when your RF value is the same, it's hard to identify the mixture's component. Okay, so the total marks for this question, which is the last question, is 14 marks. So I hope you guys enjoy the video. At least you learn something from this. So I wish you all the best for your exams, and please comment below, like the video, and please subscribe. Okay, thank you very much.